Dear students, in this class we will discuss about UV visible spectroscopy. So what do you mean by spectroscopy? Consider you have a sample. Then if you pass the light rays to the subject, there can be reflections, transmission or absorption. Spectroscopy, it is a study of interaction of light with the matter or with our specimen. Okay. There are different types of spectroscopy techniques, and today we are going to discuss about UV visible spectroscopy. If you pass UV or visible light rays to the specimen, there will be electronic transitions. That means the electrons in the lower energy states of the specimen atoms, it will absorb the light rays and will move to the higher energy levels. Okay, this is called the electronic transitions. Now we can check the wavelength of UV and visible light rays. This is the electromagnetic spectrum. From left to the right, the wavelength of the light increases and energy decreases. We know that when the wavelength decreases, the energy is going to increase. UV and visible region, it is from 100 nanometer to 800 nanometer. In UV visible spectroscopy, we will use light rays with wavelength of 200 nanometer to 800 nanometer range. In that, 200 to 400 nanometer region is ultraviolet, and from 400 to 800 nanometer, it is visible region. That is violet, indigo, blue, etc. up to red. Okay. Now we can see the different electronic transitions that can happen inside the sample. So based on molecular orbital theory, there are different molecular orbitals in terms of energy. This is the lowest energy molecular orbit, that is sigma, and corresponding to sigma, there will be highest energy level, sigma star. Then for pi molecular orbitals, there will be highest energy level, pi star. Then this n means there is energy levels of non-bonded electrons or the free electrons. Now we can check the allowed electronic transitions. Suppose there are non-bonded electrons and bonded electrons in pi and sigma molecular orbitals. If you pass light rays, the electrons will absorb this light energy and will move to the higher energy levels. Okay. So the non-bonded electrons that can move to pi star or to the sigma star. The transition will depend upon the energy supplied. That means the energy levels of the light rays you are going to supply. Similarly, the electrons in the pi, it can move towards pi star, but it cannot move to the sigma star because that is forbidden. That means it is not possible according to the molecular orbital theory. Similarly, the electrons in sigma, it can move towards sigma star. The electronic transitions, they are not same all the time. It will depend upon the energy supplied, the energy of the light rays that you pass to the sample. Okay. Here I will introduce two terms, absorbance and transmittance. Absorbance, it is also known as optical density. It is a quantity of light absorbed by your sample. This absorbed energy is used for the electronic transitions. After the absorption, a remaining light rays, it will pass through the sample. The quantity of the light that passed through the sample is known as transmittance. This is an example. This is the absorption spectra of the sample. This peak, it is the maximum absorption. At this particular wavelength, here it is 270 nanometer, lambda max is equal to 270 nanometer. So at this wavelength, the maximum allowed electronic transitions that will happen. Okay. So the absorption parameter will depend upon mainly the concentration, the type and the band gap of the material. Based on the composition of the materials, we can also observe multiple peaks in the same graph. Okay. The instrument used in UV visible spectroscopy is called the UV visible spectrophotometer. It can be either single beam or double beam. This one is single beam spectrophotometer. This is the light source. Then it is focused to the monochromator. There is a prism. It will split into different wavelengths, that is different colors. Then a particular wavelength can be selected and it is focused to the sample, and the sample will absorb certain amount of light. Then the remaining light energy it is going to transmit. The transmitted light rays, it will be captured and analyzed using a photodetector. Okay. Let us take the amount of light at wavelength lambda which is focused to the sample B I naught, and the amount of light transmitted through the sample, let it be capital I. Then the percentage of transmittance, I divided by I naught multiplied with 100. If the sample transmits all the light, the percentage of transmittance, it is going to 100. There is no absorbance. And if the sample absorbs light, that means if I is less than I naught, then the percentage of transmission will be a number less than 100. Okay. In a double beam system, the monochromatic light from the monochromator, it is split into two, a sample beam and a reference beam. The sample beam, it is passed through the sample. In the reference chamber, it is usually filled with water and it will not absorb any light. Here the absorbance will be 0. So it is taken as reference. Then the intensity of transmitted light, that is from the sample, and the light from the reference, it will be compared and analyzed using a detector. Okay. Now we can see the applications. Mainly it is used to detect the concentration of substance, then to detect the impurity levels, to detect band gap and different functional groups. It is also used to determine the molecular weight of the compounds. In the next class, we can study about PL spectroscopy. Okay, thank you.